This is hopefully something from the title here, as I titled it at first, Reverse Bell End Aerospike Engine. Now, the reason why I titled that is because it's a good idea. I was already using a bell end and aerospike combo to get the best, where I only need it out of like that kind of exhaust, capturing it both in an atmosphere, but also out of atmosphere, as I was typically often making a hollow bell end and a hollow aerospike that is a donut, a toroidal shape that's a teardrop. Okay? So, what that means is that I could get a lot with the stators there as well, with the derbuckling and the channeling and the overhangs and little wave guys on those overhangs to create a type of vortice that would then allow for fuel to come in and skip over, blend, and burn. Okay, now the reason why is as the nozzle goes through, it's quite lean. And so I can put in fuel and that would cool it from the start. And that's a type of, carburetor setup, so to speak. As it races away, it's a lower pressure. I get the Venturi, I get the Bernoulli principle kind of effect, and that acts as its own type of pump, using heat to make it more efficient, while also gaining a type of atmosphere in a bell end aerospike kind of manner. However, while as efficient as it is, it's big, hefty, it's a beefy guy. Kind of sucks as a result. So it's like, all right, well, what if I decide to change it for a reverse? And instead I made it more like an Ionic engine. It's, an entirely different version and design than what I was doing previously. So that way it's a lot less thick. And instead of needing to burn it into a chamber that goes through this little nozzle, the entirety of all of the outside of the bell end and aerospike and the inside turns into its own burn chamber. Instead of having it race through, though, it's a different style of Ionic-like. I'm passing a different type of electrostatic and electromagnetic. I'm forcing instead a type of boundary layer of plasma that once I shoot this in, it fills in the gap, and when I properly, like a pulse jet engine, fire it in the right way, it then accelerates it faster like a coil railgun. It's remarkably more efficient, and for what it's worth, it burns a hell of a lot less fuel because it gets in always a plasma that very quickly turns into not a plasma to near light speed. And any atmosphere, even in space, with a much, much smaller, much more compact design. Because I can treat the fuels like electrodes. I don't need to charge what it is you think I would have to charge. The electrons, effectively, to make an ionic. See, like I said, Ionic engine because it's like that. But no, I'm not going to do that. That's stupid. I would never do that. That's a waste of extra electricity. It's very inefficient. For the amount of energy you use, you get very little back. So I want to change the mass that I add in the overall acceleration that I want to get out of it. Not based upon electricity, but stored inside of the chamber itself and what's allowed to release. Now, this means it's very, very much a different beast altogether. I don't have to spin things. I don't have to keep it going. I don't have to do anything. In fact, all I'm technically doing is burning it anyways, just like before, but making sure that it separates the right way, and in so doing, loses heat, the energy that's already contained in it, and orders itself to give me an opposite reaction to the given energy I capture from that system to make the whole thing run. That's right, I have to draw energy out, not just heat, but electricity, making it far more energy efficient. The Q value goes way up. I get near light speed for the given amount of heat that I have to put in. However, that means that, like any other Stirling engine, as I let some of it out, I get an opposite reaction, which is work energy of thrust in space that no longer needs me to have a ridiculously over the top sized bell end. It's contained, it's perfectly situated inside of this little area, and it pushes directly onto it. And in fact, because I do it so well like that, that means I'm always able to get all of the given amount of thrust possible for that given amount of mass leaving. Which means I can tailor it exactingly to my current speed. Now, if I have this amount of mass for a ship, and I need this amount of mass at this speed to accelerate it this fast, acceleration squared force, blah, blah. A little joke in there. Little G force joke, But what that means is I get far more efficiency. A lot more. A lot. I don't need a gas like any other gas. I don't need a xenon. I don't need any of that. Combustible gases will work. So I developed a type of dissolvable solid fuel oxidizer explosive that would dissolve into a type of fuel and oxidizer together that, when the right circumstances, conditions are met, they'll actually burn. But they don't until then. No matter how much you try, until you get the right fucking shit going, they go, I'm still stable. I don't care. Which is essentially the equivalent of, what's up, thermite? Look at all this oxygen and electricity I'm fucking getting from this. That's a hell of a lot of mass over there in a fucking low pressure environment that happens to do all the vaporization real simple like. It's pretty easily cartable around, as a magnetohydrodynamic kind of pump could probably work. I don't really want that oxygen there yet. So, no matter how much you mix them together, they remain pretty steadfastly stable. Those damn bastards. Oh no! Anyways, however, these are not typical thermites. I said like a thermite. Keyword like. As I don't want to cart around heavy, solid dust around nano-sized particles of oxidized compounds. Not usually my favorite activity, Typically, I was more of the liquid guy, personally. But because I have to mix in a solid here that has to go into a liquid, that has to dissolve into that, there's usually only a few that are typically possible. Now, the one that I developed, shockingly, is a methyl trimethyl. It's methyl tri, actually, is really what this would be. But it's a nitromethane connected to a hydrocarbon, because that's nitromethane, but a nitroglycerin. It's a methyl trinitroglycerin. However, there's a nitromethane and an extra bit of oxygen connected to it, and when it precipitates out of this from organic, then it goes into a catalyst synthetic, and then into a organic, which then goes into a synthetic final, which has to have electricity and not just with the catalyst, but the right light that has to go to it, and the right pressure and exothermics, and then it precipitates out. Actually, there's a couple of stages. Point is, that's kind of the whole point. It's sort of like a bioreactor sort of setup. Anyways, the reason why I wanted to make it is because it makes total sense to make a terrarium bioreactor combo, kind of like our digestive system is, to make, ultimately speaking, a result of something out that I can now use as fuel. But also it cleans the air, which is wonderful. So as air passes through, it does its thing. We get a little bit of electricity. Now I have this little undulating, because it uses piezoelectrics, type of pump. Now, it's not really a pump because it's technically more like a turbine, except the turbine makes it so that way it can feed in the catalysts and more to charge and get real close to immediately separating certain things as I fire it into the actual combustion chamber, which is really the aerospike bell end, as if that is what it is, except it's not. You see what I mean? Like, oh no, it is burning over here, right? As it goes through. And oh no, it's surviving. You know, it's cool enough. It's like a Stirling kind of. It's not really a Stirling. You know, it just goes through and it moves it, right? Because we want to retain some of that heat, right? And we want to keep it cold enough so that way it's not going to die. You know, that kind of thing. Standard stuff. Now the boundary layer is not so bad, and the magnetohydrodynamic pump is not as necessary, we'll say, as I can both cool it and keep it around a nice degree of permanent magnets that are, of course, attached along with a nice switchable magnetic field for coils that can be in the area that I can feed some of that electricity as it goes through. Anyways, as it goes off into this point, of course, I only need to feed it the right amount. Now, I get far more electricity out of this because of the exothermic reactivity, and truthfully, I'm getting more energy from the sun still. You know, that whole big thing, fusion with light and stuff. Still providing that energy, you know. Cool stuff, right? Anyways, still making me electricity, obvi, right? And we just feed it some stuff, clearly. You know, our fecal matter, our urine, anything that we don't want. You know, like a person that's being a dick. Maybe they just died. I don't know. Nobody will know. Who would know? Not really. I'm sure people would know. Point is, though. The point is that, yeah, no, we could do that. Now, granted, my whole thing was, well, see, the reason why I made this is because it makes sense for this kind of near plasma, very charged like state that creates its own type of field effect to neutrons. Different types of neutrons exist, and we detect them for what it's worth, although very small amounts. But I'm not looking to get large amounts. I'm looking for any amount that I can force into a smaller area like this, and fissile to a degree, by technically giving them this little, hey, what are you doing on me? Hey, sort of effect. You know, a good old fissile effect, making them a little heavier and a little less stable. There's a fat joke in there about some people with insecurity, I'm sure. Anyways, or, you know, single mothers and fathers. Low-hanging fruit on that one. Point is, it is a quasi-ghost, essentially, that doesn't technically exist. It does exist, but it doesn't really. You know, it's not a virtual. It does exist, but it, you know, it's that thing with quantum physics that I don't like to talk about, where we end up discovering how to phrase something that essentially means we have an out at the end of it. If it turns out there isn't a thing there and it was something else, or if there was a thing, it turned out. At least that's my interpretation of how it is that they phrase some of these things, because of the words that like interference. It's like the block. It's like a bouncer in a club. You ever think about that? It's not interactivity. No. And then it changes ultimately the results, right? But that's quanta, I suppose. You know, but I don't know. I mean, oh no, we fucked and we're good and now we've transformed into this baby. You know, but of course we're around, I swear. Something like that. I want to move on. Point is, what it really means is that we're creating effectively a type of effect to that given neutron that's kind of getting more ordered in a given direction, right? As we're capturing it during that by more than anything, having it align with the things that we would try and detect it anyways. Meaning there's very little things that will affect a neutron, right? But things do. And we are going to use that to our advantage to try and force it to fissile. by trying to make it think both it's attached to something, but also that there are multiples of them attached to the self, which they don't like. Neutrons don't like to become neutron star matter, no matter how much you try and cool them or corral them together. They need a lot more pressure, so you're not getting around that. But you know what you can do is cause them to think that they're all of a sudden connected, and then they start acting weirdly like a very heavy element, where they'll try and fissile. They become more easily able to do that. Well, luckily, they're heading into a rather hyperdense bell end aerospike combo. That's right. To its view of things, it goes, yes, but actually, you see, the thing of it was, stop doing this. No! My plan to say this is not possible. No, well, the standard, it's a lot denser than you would expect. It's not the core of a star in any aspect, in any kind of way. No. But what it does ultimately give us is a type of massively forced into a given arrangement that appears at first as if it's far colder than it would be, except it's not like that. Right? And they just sort of situate and fit in between themselves. Think like grid lines, right? For lasers, as they aren't touching, but they're quite close and they won't interfere. But you can do that in many, many, many different angles, it turns out, and still not ultimately have them ever hit. And if you happen to move them around and do a little chiral spiral DNA stuff, turns out even further you can get that to work in your favor. Well, because it's shaped very much for that, to start it off to begin with. Because that's basic fluid dynamics of a vortex in an aspect, except I don't need a vortex. I need a destructive and constructive interference that's constantly resonating, that applies a given backwards and forwards type of direction of an equal, opposite, in and out rotative force, much like the convection currents that our star, the sun, happens to have, we theorize, from its core to its surface. Well, because it's traveling a lot faster around the surface of any of these things versus the center, it means that we get a lot less dense there, and we can always add more. It always has a stored version of kinetic. Sort of. It's more of a resonance. Now, the reason why this works is very much both from the static and moving of effectively pressure, heat, in this sense. As I remove that, it now has a place to go. But you see, in so doing, it only has one place to really go. The way we want it. Where we moved a space for it to go into. I.e., that way is the opposite direction of where we're traveling. So that's where I want you to go. And guess what? It went that way. Fast. But because I fissiled a massive amount, because comparatively to the amount that we're actually going to do, it is amount, because there's a shit ton around us, and we're going to try, but I always say, but c'est la vie, life goes on, we keep going. A standard thing, right? Life. I try. Point is, though, instead of capturing the mass, we're using that as a type of, think scram. We're adding in a type of interactivity, interference, and a given mass profile that gets captured into the mass escaping. That also allows for kind of like a tube TV as we fire photons, right? Out of tube TV. Well, this one's a little different. We get some plasma that's in the quark range usually, except it doesn't like to stay that way. Clearly, they're all like, no, I will be something else. I need to be anything other than I am. I am nothing without my partners and my polycule. I need to elementize. So, anyways, it tries to adhere itself to a lot of other people, making them typically a little less on the not so heavy side and a little less on the not so stable side. You know what I mean? Well, because they're resonating and constructively interfering as, well, they're not even a plasma just yet. You see, we force it into a plasma, and then we cool that, and of course it comes out as a regular gas. Now, it might be burning, sure, but we have to keep it a certain amount of temperature no matter what. I mean, this will be fine to do that. And it can even work in our atmosphere, which is wonderful. The problem is of course, it escapes at fucking near light speed. And it's quite heavy. So it comes out as a very weird gas. A very odd, like, for what it's worth, I never really tell anybody, like, what that liquid is, because I don't really want people to, like, know how to mix explosives into a solution that can explode. I'm not a big fan of that one. You know, I'm not like, man, nitroglycerin and a fucking solid explosive should get together. No, let's put some thermite in there. No! That'll be fine, he said. I didn't say that. Who the fuck is he? Oh, that's someone else. Oh, yeah, thank God. Whew. Dodge that one. ATF would like to have a word of you. With you, not of you. Who's of you? Anyways, the point is, however, that yes, while it's possible to do this, because you should do that, you know, thinking before you go, no, then you end up going into a different area of like, well, that's cool for this neutron thing. Can we do that? Well, actually, yes, we can do that. We've been able to do that for a while, although I'm not going to explain that too much in depth, but for what it's worth, if we can create positrons, we can definitely create some neutron fizzling events, which aren't technically what that is to them. And I'm like, potato, patata, it's the same thing. You're breaking apart neutrons. Point is, though, what comes out is a bunch of quarks that typically will massively accelerate things, because it's like the potential kinetic we get in an exothermic reactivity of an electron trying to move closer to its nucleus. There you go. Nucleus of an atom in an exothermic reactive way. Now, what that usually means is there's a spring as it tends to flip and it curves off. It then flings it off and it creates a rotative, swirly, corkscrewy, chirally, DNA, all that shit movement that we see as a randomness. But that's all based upon where it happens to land. And any given fucking stupid Heisenberg uncertainty field bullshit. Inclination, orbit, crap, spin dynamic, and fucking God. And so we go, we throw up our hands, we throw papers off a desk, put our pencil down. Fuck you. It's just potential kinetic. It's not even a thing. Don't even worry about it. It's not a thing. Don't worry about it. We're not going to fucking ever think about this again. Proceed to look at a bunch of quantum fucking physicists just go, we're still trying to think of. We don't even know how to control that stupid shit. Proceed to look at a whole bunch of other ones. Not here. We're going to leave. We're trying to think about exactly how to control it. Turns out there's a lot of people trying to figure out a lot of those things. But currently, right now, our best efforts are, it's likelier like this. Yep. Yeah, that's standard problem. Anyways, right? Then we go into the unfortunate truth of why the hell would a quark fucking do this? Well, because you see, the quark is not really the big thing. A bunch of quarks moving like this and deciding to adhere themselves to other charge bullshit effectively that's around, that is potential energy that it's imparting into itself as it travels towards these other things that want to move this way anyways, then give it a good acceleratory push, so to speak. as they are, of course, a lot less massive, and then they carry with them a change to the potential nature, that is, not of mass, so to speak, no, more than anything, actually, because it's rather small mass. Quarks are like nothing, essentially. It's more about the fact that there's a bunch of fields that are involved. We're talking about electrostatic and electromagnetic potential snaps. Think corona mass ejections. And they're going to snap a given type of direction, sort of a thing, which is why the quarks kind of are so important in that sense. There's no fusion, luckily, which is nice. Because fusion creates more neutrons than it's ever been worth to have happen. So, don't want to do that usually. This also makes it ridiculously low light and low energy once we get there. It takes a degree of energy to get it, like a Stirling engine, going, and then once it does, it continues to do this for a really long time, which is very, very nice. Right? No. The other issue is typically always the one that nobody wants to talk about. It's never been done before. It's puzzle piecing a bunch of things we have done before together and a few experimental ways and designs together to make it all work very, very efficiently and effectively, which is one of the reasons why I happen to want to do it. Because I'm firing in effectively a jet of fucking quark plasma, which we've made before. From neutrons, however, we have not. But we've certainly made quark plasma from neutrons, and even using the neutrons around us that pass by. Crazy stuff, though, as these are usually in the bleeding edge and so on, or one-off little things that people do in highly experimental manners. Well, I'm not usually one to care. I'm usually that guy that goes, fuck that bullshit, I can use that anyways. What if we just got a little bit of extra? Like, that's all we need. Even a small amount of quark plasma that we're separating using those fields and electrostatics, which, by the way, fields is so passé. They like, tell us these types of charge chiralities of this different type of electromagnetic collapse for the magnetohydrodynamic principles that I must adhere to this given type of plasma. And I'm like, most people don't have PhDs in this. Could you go away? Could you please leave? No one wants to hear that. I have to create an opposing... By the way, that's a fucking weird one, isn't it? I have to get an opposing fucking quark gluonic style of fake field. You know what I mean? Which effectively means I have to pulse a bunch of material with electricity the right way, with a field effect up on the opposite. So like we're talking coils that are layered the right way in a PCB that then runs through and pulses together correctly with this given type of material that has electricity running through it that gives us that type of effect. Such a weird phenomenon, and even then I still have to get photons involved. It's like, no, it needs to be slightly reflective here and here and here, and I need to run this reflectivity beam bullshit over through this way. Let me see my fucking coherent effect. Oh yes, no, and my fiber optics will join in. Oh yes, but it will work. The lens together, combined with the two-way mirror principle Lindsay thingy, will definitely do its bestest to effectively fire in light correctly in the appropriate manner and wave frequency at the right times, at the right given amount of luminosity and input power. For the right frequencies, yes, and the right pulsing, and all this other fucking wave stuff, all to essentially force a type of, I'm definitely this thing that you want. Come on. And you don't want to be around here. Shoo. Get out of here. This is about the max it can do. Such neutrons that I have to fissile pretty quickly, by the way. Which isn't the hardest thing for what it's worth. It's just that it's annoying. Yeah, because it's like, look at me. I'm a bunch of very intensely exothermic potential gases right now. And as I go through this, I create my own electrostatic and electron redox flow forces, which is a different type of thing. Instead of Lorentz, we get a different force altogether. I'd have to call it a Lemke force because I'm not really sure what the hell it's called. But it effectively creates a chirality that intersects itself and collapses inwards and then rebounds off. Anyways, now that usually helps with the kinetic potential problem, right? And I've been solving my own fluid dynamic problem with quantum field theory for a long time in quantized manners to large scales. So I've never really had a problem with it. I just call it a Lemke principle, for what it's worth. So I moved on to like, well, with the right light, that actually works astoundingly well for separating quarks. Now, gluons get stuck to them, and that's wonderful. We want that, because they're now going to stick to the fucking gas in there. And I do need, wonderfully, enough electricity. Well, I've got piezoelectrics. They get about 90% of that electricity of a burn. However, because they're already accelerating one way, and then they're getting separated and cooled, and to a degree, charged during that, then we're adding in some nice thickening of some neutron movement in sections that get corralled into different areas of tubes and reflectivity profiles, so on. And then they start passing through these types of fields, right? And then we get the right little material as they try and pass through. Now, materials aren't super wonderful because no matter how dense we make them, there's a huge amount of distance in between them, right? Well, this is where like graphene and graphite really start playing a role in your idea of how to look at this. So a 2-layer graphite, just graphite, but it's of course not a graphene layered properly, that kind of thing. They intersect in between. That little, looks like almost like a benzene. It's a 6-sided hexagon, right? But it's like, imagine if you filled up the hexagon, both at the top and at the bottom. And then you intersected graphite like that, effectively, in a different manner altogether, where you stuck graphene diagonally in all 360-degree ways, in all horizontal ways, and all vertical ways. And then you decided to compress it by condensing it, and then metastabling it by effectively putting a shell around it of very hard substances, and then you shocked the fuck out of it by, after condensing it and putting it in a really cold state, and then you compressed it even further, and you cooled it off and all that. And then we're like, and now here's a bunch of electron movement, like turned into a plasma level, but in very specific areas. So I will force plasma here, but not really. I'm just trying to make that happen, right? So electrons move, heat tends to occur, right? And it's like, yes, yank, yank, yank resonances start to occur, and some push, push, push resonance starts to occur. Now imagine if you did that the right way with the right materials. Instead of using carbon, it was an example. I'm not using carbon. I would never use carbon. This would be a bad idea. All you're going to do is make one hell of a lump of carbon that's quite pure, but very difficult to get turned into anything else. It's extraordinarily, stupidly strong at being a fucking carbon ball. It sucks, actually. It's super difficult to deal with. No, but see, the thing is, if you heat it up right, ablating away. Fuck off. All the work I did to you. God. I basically made a super carbon onion ball, basically. But if you do that the right way, they jiggle and they wiggle, they cool off, and the electrons kind of like go back and they intersect at various lower depth area of electron orbits, right? But then they connect in many more ways. See the first 6 sides, right? Like, get on, connect to these 6 sides. Like, no. All 6 sides are basically down to the fucking nucleus. That's right, which isn't really what that's called, but we're going to move on because protons and neutrons, and I have a little ball around that's very uncertain and quite field-like in its area it exists. Much like the orbits. I say it's there, but, who can tell? So we're going to move on from that one because that's basically what it kind of feels like. A nucleus, kind of like our cell. It's definitely there. Yeah, but you fucking destroyed it to know. Shut up. Anyways, we're going to move on to, of course, that means that the nucleuses don't really understand that they're not actually that close to each other. It remains remarkably hard and remarkably stable and stupendously dense. It is a hyper-dense material that makes no fucking sense because it acts very similarly to like a neutron star degeneracy pressure atom. Even though it's definitely not, and it's not that heavy, and in fact, it's just mimicking it really, really well. So no matter how hard you try and convince others that that's what you're doing, no. This is the only thing it is, okay? It's just some atoms intersecting correctly, so that way it's both very stable and incredibly dense, making neutrons more likely to be affected by electromagnetic and electro fields. See, I can create very odd profiles that make neutrons think, truthfully speaking, because even though they are this small, they still get affected by incredibly strong fields that are going on. These are charge fields, effectively, right? And even though this neutron is really very, very small, it's a subatomic particle, right? Well, an electron is not very big. So they're pretty intense with like where they are and their orbit. And because they're zipping around the right way, and as neutrons tend to do, they get through this material, sure, quite easily, usually, right? They tend to slip on through, typically without much of an interference of the quantum wave that they are as a function. Well, now the wave function doesn't work quite the same way. Instead of a 2D model, you'd be using a cloud-based model in a thermodynamic manner. We're using differences of pressure in the oscillations as they go through, and the resonances that are happening, and the result of change of spin and charge that starts forcing them to rip apart, kind of. It's not really doing that, though. It's hearing something, and then it's like, no, but you're kind of like with me over here, right? And then it goes yank. And it really thinks it's a big thing now, real super big neutron somehow, and it can't do that. All right, so it tries to get closer, and then it goes, oh, no. And it rips itself apart. Basically, by using potential kinetic, which we have an awful lot of, don't we? Because I need to keep this thing cool, so I'm cooling it with neutrons passing through. By using neutrons that are always around us as a neutral plasma that's always going on, that happens to now be used for this very effect. I made a neutral plasma work for me. I made work energy from a neutral plasma. Now, the reason for it happens to be really pretty much one that I ever really want to come up with. It's really energy efficient. It's extraordinarily energy efficient. We have never-ending amounts of neutrons. There's nothing but extra neutrons everywhere around us. So, we now have an atmosphere we can finally grab onto and burn. NASA would be proud. It's too bad they never look at my shit. Fuck you too, NASA. Anyways, here's how to burn neutrons. And using the light that, of course, gets elicited from this, and, of course, light that, we can effectively try and use during the exothermic reactivity, and of course the fact that we're next to a big ball of light, more or less, that helps with us to force it to be a little bit better at doing this. Light's always pretty good at that, you know. Despite it not having mass, it definitely does tend to try and move things when you do it the right way. It's a thing, yeah. But the cool part is, have you ever thought about light just decaying into the point where it looks like a quantum vacuum pressure? Pressure, right? Acceleration. Like, it traveled so far, it started to decay into such an elongated thing, it now just started moving reality. Have you ever thought about that? Like space-time. Space-tons and time-tons. Whee! Getting moved by light. The infoton pon bonds and all the rest of the ons. Whee! My ons just getting pushed. Because for us, they're quite neutral. They don't have a mass. They wouldn't even look like they exist, obviously. So instead of it decaying, it would just be another form of light that we were just totally unaware was a thing. But it's like a big old pushing light force. And thermodynamics, making it all work very much like your little fucking dark energy and matter happens to work like that. Gravity happens to be a different form of electromagnetic. It travels for a longer degree of distance to become super long and pushy, to the point where it snaps back and jiggles backwards as a reverse dielectromagnetic attractive pump. Shut up over there, you dick fuck. It's a big old charge field. Give me your energy. Become more ordered as a result, as you have to travel along the field lines that exist. Making it so entropy continues and you clump around and I get more around me. Thus making it so that way it's less chaotic and disordered everywhere. Because gravity exists. But it would make sense because we've always theorized that electromagnetic and gravity forces are intertwined. But it's, what it is. Once you get them really hot and pressurized, we're together. They tend to get together, That's this theory, that we have in quantum field theory. But, whatever. What if this, though? I use it as a thermodynamic versus that, though. You see, I don't really like the idea of electromagnetism and gravity being like that. They'd be two sides of a supersymmetrical coin type of thing. Where it's like, well, this is not a charge. See, gravity isn't going to be a charge. It will definitely be a type of energy and force, sure, but we're talking about a harmonic resonance inward bound. See, it flips the script on a type of directionality and movement back towards the center. Instead, it doesn't do that. It instead happens to interact with space and time to a degree, because, of course, that's a boson field, right? It gives it the mass, but of course mass has to transfer its information anywhere. Well, information in any nuclear and electromagnetic and so on happens to need to go quite far, and it's not traveled along just by light. Those are different types of fields. Those are field forces. That's quantum field theory, though, for you. This is why I call them the infotons and bonds and more of the ons. As much as it is a bit of a joke, it's also not fully a joke, unfortunately. My inflatons! Yes, well, they're a particle duality, aren't they? Look at my field of harmonic resonance of decayed fucking movie move stuff of kinetic that, informationally speaking, transferred as it moved into a lower and lower elongated state of pushing on other fields. Wow, look at that resonance, man. That's constructive. Meanwhile, no, you can't do this with neutrons. Are you fucking kidding me? It would have been no. Fuck you, shut up over there. You can't be doing nothing with no neutrons over here. You suck. Suck it. Suck it. Ah, I can. Suck it. Anyways, the point I'm trying to make is that I wanted to turn what's already around us into something I can actually use feasibly. Now, granted, it does take a degree of actual energy to do this. It does take a decent amount of electricity, and it does take a considerable amount of research and development. The right materials, the right structuring of those materials, the right electricity, the right charge, the right light waves, and more. All right, we got to do all of that work. But what I managed to do for a concept is from like, a bellend that would be kind of like the size of a small house here. Once you get up into space and it fully unfurls and so on. Yeah, because it has to elongate, and then there's a little lash, and there's a little twisty thing, right? And then it's like, oh, look at me, I'm a big old fucking aerospiky bell-end thing. It's huge. And on the ground, it's fine. It wasn't even really necessary. If anything, And now it's like, well, geez. Compensating? No, I need to go faster. I need to capture every little bit of this efficiency I can. Plus, the larger the surface area, the greater amount of cooling I get, which is wonderful. That's what I need, It's thinner, it's lighter technically than the mainsail of a regular Saturn V, although they have lighter ones now, so. As a result, it's, not as bad, and it's far less complicated, which is nice. Which means it's cheaper, which is also nice, which is why I kept touting it for so long, and I kept working on it on my YouTube channel. It's concept until eventually I went to this point where I was like, what if I just reverse this? This is getting stupid. I need this to get a lot smaller. This is annoying. That's failure points. I don't want any failure points. There's basically no moving parts here. I mean, there's some bendy, undulaty, parts. That's it. Otherwise, there's a bunch of fields and some stuff that I can replace if I just take it out and put it back in. Just like a filter, basically. This is way easier. This is way better. Behold my cool intake system to my engines. These bad boys suck in so much shit. Let me tell you. I want particles to be going this fast. I'll be doing so much fusion, it'll be like nothing. Meanwhile, my own dumbass as well. No, I'm not gonna do that. You get out of here, you. You stupid particle accelerator, bitch. You. I started looking into like small wormhole, like my quantum tunnel, bare minimum wormhole tech, into more and more kind of like levels of how I could possibly put it into a skin, right? But I wanted to do better than what that was. All right, so like this was mostly just so that way I can get from Earth to Mars in an airship vacuum design. So it's a vacuum airship, very buoyant as a result, right? But like the skin that I made it out of is a different type of version of like what I just described. Except this time it is, well, yes, it is carbon. It is a very unreactive carbon. You could definitely turn this into 4,000 degrees C and it wouldn't care, which is kind of a problem of forever chemical. So I had to change it slightly, which is why I haven't done the V3 yet, even though that was Escape Lane V2 and my audio blog that I talked about some of these other designs. All right. However, and how to manufacture them and even make a really huge, massive airship that like would literally make everything we've ever made look small. Like the Burj Khalifa. Yeah. Look at this thing. Whoa, whoa. I just exist on surfing the whole thing called the slipstream over here. Look at this. I've got a whole city in the sky. That's probably not great for them. But you know what? My 150 million people that live on this are probably happy. It's a different type of multi-delta kind of torpedo-ish shape. I'm going to move on. Yeah, because it doesn't really matter. Mostly because in order to get that funded, I'm sure it'll just turn into a big old weighing dick eventually. As it happens, usually it seems like. So, this one turned into something else though. Okay, like I had to make a different type of material for the inside of this bell end, anyways. Right? So, it makes sense to do something entirely different for the skin as well. So that way I could just not ever have to worry about re-entry. Although, yeah, no, I can get to a thermosphere pretty easily, truthfully. It wouldn't take very much. I just need to get like to a certain speed, and then I'm up into the thermosphere, and then it's just a short burn to get to orbit and stay there, which is low Earth orbit. That's thermosphere. So that's where the ISS lives, anyways, last I checked. However, I want to do a little bit more than that. And so I had to get like a little bit craftier because I don't really like re-entry gases doing things I don't like. So heat and the given composition of the gases that are producing that through friction are what you have to contend with. Standard bullshit, right? Well, it turns out you don't need to cool it actively, although you could do that. It's not impossible. It's just annoying. Yeah. Like for what it's worth, it's like a little annoying to actually have to do it. Usually it requires a T-junction with these little turbuckle and then waveguides that like curve inward to create a bunch of little cooling, fin slowing down air kind of channels inside of like the bottom of a whale kind of air channel, but that's fluid, that's water. So like you do a similar version and you basically get a very similar effect. Now, granted, you have to put, the same kind of thing in the T as well. So that way, like, it creates a multitude of these types of different vortices that then smooth themselves out and create a definite pocket, an air pocket of both a cooling air plug and then an actual air plug that allows for, in no way, for the actual air to touch those areas. You start it off with a little bit of nitrogen, and the rest pretty much takes care of itself once you get the necessary speed during re-entry. Which means you can comparatively use a lot less. Now, the problem is they're typically annoying, for what it's worth, to manufacture-ish. It's more about the fact that you have to replace them. I don't like doing that. It's fucking stupidly annoying. I hate it. It's the worst. I hate doing it. I would never do it. Like, I want it to be exactly this, and I don't have to do anything for a really long time. Fuck off. I'm that guy. Like, oh, I have to change out my tires? I don't want to change out my tires. Fuck this. I want my tires to be good for the entire life of the vehicle. I literally never want to fucking touch those. Meanwhile, I'll change all my tires. Are you okay? I'll definitely wear those tires. Meanwhile, I'm sitting over here with my permanent tires, fucking screaming around fucking Formula One tech people. It's like a nothing. But granted, I don't have fuel restrictions, so that's not as hard for me. Anyways, so what I decided to do is a type of structure of lithography and electroplating, basically. A plasma and regular solution electroplating. That's right, with a nice little kick with a particle accelerator. Turns out it's pretty good at making certain things happen when you run electricity during electroplating and a little bit of photolithography for growing certain types of constructive materials, and large scale, no less. Who would have thought? Yeah, so what that meant was there's some carbon, there's some iodine, there's some bismuth, cool stuff, right? We got some of that zircon, otherwise known as zirconium. We got some silicon in there. There's very little of the iron and aluminums. I'm not a big fan of those things. There's no phosphorus, can't be using phosphorus. There's one noble gas, hazard gas. Krypton? No. No krypton. Sorry. Helium. Yeah, I used helium, weirdly enough. I don't know how I fucking did that. Oh, actually, I do. Because I did that. Good old pow with an accelerative force. Yeah, what's that particle accelerator doing? Oh, no! My helium! No! Turns out, though, it produces a very lovely effect when you do it right. Because it's only got the 2 electrons. When you remove those 2 electrons and turn into a plasma briefly, luckily, it likes to combine with certain things because it sees itself for a moment as a very different, kind of compound, ready to be made element. Right? It's under a lot more pressure and a lot more stress. That kind of thing. So, however, the helium is genuinely just there as a placeholder, a small little catalyst, if you will. And it basically gets stuck in the reaction, and so it just never leaves. I'm not even kidding. There's boron there. That's kind of the only real metal that would technically be involved. Because a lot of the rest of it's organic. Because it needs to be flexible. That's right. It has to be flexible and repairable. I have a little powder coat that I just spray onto this thing. And then, like, in the vacuum of space, and I just allow it to roll a little bit and point towards the sun. It heats itself up and cools itself off enough times, and with the right little electricity difference, it's like a powder coat, right? But a little electromagnetic and a little bit of light to constructively interfere and coherent itself onto the surface the right way, I get a very strong adhering effect that rebuilds any ablated away material, which is wonderful. Now, PTFEs suck, right? But almost every chemical will break down if you do enough to it. Right. Well, there's a whole middle section here that we haven't used, right? No. No, I don't want to. No one likes using this place. Go away. Yes, well, unfortunately, iron's not available, and I'll never use nickel. So, 10 points to anyone out there. Internet bragging points if you get the right element. Now, granted, there's only so many, so one of you will definitely get it. And it is the middle, and it is the first and second row for what it is worth. That massively narrows it down to a lot, yeah, of different types of combinations, because it all depends on how it is that you react them in that electroplating, which is what I meant by electrolysis in quite a few of my other videos, for what it's worth. But it's kind of a version of electrolysis, because you have to ablate it away, and then you have to plate it into something else. So it really depends on what you're trying to talk about there. Now, phosphorus can't be used, obviously. We're talking about a slight organic-like setup, right? But of course, we're doing it in a very synthetic manner. Now, the reason this is such a big deal is because it forces it to create a multi-intersectional puzzle piece together compound. As in, it's polystructurally a thing that's polymerized with adhered polystructural polymerization tertiary compounds, i.e. I formed a matrice, a skin-like structure matrice. You see, our skin has a bunch of intersecting cells that have a bunch of little things that connect them. There's those that are also not just there. They connect other cells that are not just the skin cells, because we have hair cells and more, right? So if you want that to work the right way, you have to do that. Because I also have to put in solar cells, piezoelectrics, and more, all of which have to move. I also have thermophotovoltaic and thermoelectric generating materials in this. all of which have to be bendy and flexible and survive re-entry very easily because they're very unreactive to basically any reactive compound at very high temperature, because they support one another to effectively create a type of electromagnetic and electrostatic type of conductivity that repels basically any electrochemical reaction, and light-based. But if you get it hot enough in a vacuum and you expose it very much to a hell of a lot of pressure and a decently much faster type of plasma at that point, then it'll finally burn. But it has to be like a plasma that has almost no electrons left into it. And it has to be a fairly large element at that, typically in the iron range. Which is another reason why, you can absolutely put this on the ground, and if you, ultimately speaking, don't make sure to wash it every so often and clear coat, whatever you need to do really to make sure microbes and more don't get into it, then it'll last. But if it does happen to get into it, it'll biodegrade that fucker so hard it does not care. Instead of oxidizing, it cleaves little things and it fucking slowly eats away at the skin. Much like us, effectively. Those damn bastards. They get into everything. But one little re-entry ought to take care of them. Usually, or one exposure to some very high altitude typically kills them all too. Wouldn't you know? So, usually, as long as you're still using your spaceship, you should be fine. That kind of thing. But if you're not, then you should definitely get something on it so that way it won't, ultimately speaking, get slowly but surely biodegraded and consumed by every nature around us. But if there's no actual bioorganic processes, it should not degrade in a regular atmosphere. But if the atmosphere was a bunch of like gas that was organic, that would help them break that down with the right light, then it would do that. It would still do that. So, but that would probably eat almost anything for what it's worth, except for like, I guess, glass or other stuff like that. Yeah, it's like they're really good at cleaving almost any kind of fucking bond. They're just insanely good at it. All they have is a little bit of electricity, a little bit of light, and the right like little catalysts and physical kinetic, right? And next thing you know, and it's broken apart. They're like little nanobots that know just what to do. The original nanobots, for what it's worth, because they existed here well before we did. So, anyways, but that's kind of where that kind of thing is. I had to use these very specific combinations so that way it'd be very biodegradable and yet incredibly strong in any atmosphere, basically. Still somewhat, quite flexible, but it's still somewhat rigid. So, like, that means with the right structure, you can then, both spread it out, but also layer it so that way it is able to do that even better. The standard accordion or, sliding kind of thing, and a little stretch there and a little latch system. That all depends on how you want to do it, really. I usually use the slide and latch method. I'm a big fan of that with a little bit of extra skin drag because I can usually tighten that up a bit, erect it a little bit more, engorge it just a little bit. Typically, I want to actively cool it anyways. Not really. I don't have to. But, it looks cool when I use that as a method to the madness of a much smaller design for the whale and top part, because I usually have it as a hollow toroidal teardrop. Yes, no, the eye of the penis, right? Yeah, no. But yeah, sure, yes, it's the eye of the, it's the eye of the penis, yep. It's really just because when it's turbuckled and it's properly channeled from there, both on the inside and outside, it creates a remarkably efficient shape for going through any fluid, basically in a nearly straight line. And it can also turn pretty darn quickly because all it has to do is bend slightly, and it tends to create enough of a force to get it to curve tremendously well and quite smoothly. It just means that like you're flying a tube that bends a little bit, and yet it does it very well. So shut up, you little naysaying prick. Especially when I can open up the turbuckles, I can extend them a little bit. I can be a little hollow. I can kind of open them up more on one side, and that way it captures a little bit more and shape those to have it be a little bit more turbuckly / more smooth. That way it grabs it and allows for a greater change of both vortice and overall lifting body to lift or drag or whatever you really are looking for on that one. Because I need to energize the bottom. Okay, yeah, all right. Well, the lifting body characteristic is still quite energized, and it's got buoyancy. So, it's just a little flatter, a little wider, I guess, at the bottom than it is at the top. And it has like the sides effectively curved the right little way with the waveguide, so that way it creates a greater degree of vortice at the top that allows for more of that lift that you're looking for. Because it both stalls it, but also skips it off. So a little bit sticks around and travels rearward, so that way it removes the dead zone, so to speak. But it also is not fully removed, as it kind of hangs around a little bit, which is what you want, because then that's kind of like an intentional stall. But that creates a wonderfully low drag, high lift characteristic for a lifting body. Which is good, especially when the testicles in the rear, as I was forced to make this. Seriously, whole thing with my mind, it's like, no, just because it's you and I'm a dick, I'll give you the money, but you're going to have to do it this way. Okay, well, I'll make it in the shape of a penis. It's a very efficient shape anyways. It's a very good, penetratively speaking, efficient shape. And we'll be going through the atmosphere quite quickly, so it's easier at that point to get through. The standard, I'm seeing silver linings. That's all. It's positives here. Only positives. That's all I'm going to do. That's a good ballast anyways. That's where I want all of my... Well, we're housing you and or fuel. It depends, truthfully. Yeah. Really. Yeah, well, you'll be going into the shaft area anyway, so as that closes up, right, and then becomes like effectively a sealed area, and then that's a huge vacuum now, right? That's a big area that you can now go into, and then from that side where you are, then you have this massive extra area that you can exist in, which is wonderful. Of course, in order to do that, other things have to move into that spot that used to be there, which is fine. It's just shifting some of the tubes around and some valves, and what happens is it now goes through that. But it's sort of doing the reverse of I wanted to come out to the tip, obviously. Of course. Yeah. Right. Well, I mean, I need that to be flared now anyways. I didn't want it to fully close or something. I don't fucking know. It's going to be a big bell end at this point. It'll be fine. I'll make it undulate just for you two. You'll sit in a nice, comfy, very still area, and the rest will move around you. So that way you have a bunch of padding, and it's quite pleasant to go through atmospheres, that kind of thing. Like shocks and springs. It's suspension, basically. It only need to every so often. Anyways, there's a bit of a time period in between each one. No, not really. For what it's worth, I wouldn't do that. But God, I could though. For what it's worth, it would be more efficient in all aspects. It's sort of a problem. Oh man, I know, but it's see the thing is like it would be, but I want to maintain a 1G acceleration. So that's kind of my problem, right? So like I could do a and there we go, and there we go, and there we go, or a there we go, oh oh oh, and there we go, oh oh oh, that kind of thing. Because it would be a little bit more efficient. Yes, well, it is supposed to be about efficiency for what it's worth, but I don't know. Like my main real one that I really did want to try was a collective series of more delta E ish tube shapes that were strung together in a kind of like tri wing almost, but then like layered front and back. And then that would be like a very different type of structure that can change its shape, and you can stay in the middle, and then the rest of that can move around, and you can basically weather all the storms and more and get a fuck ton of extra lift as you can make that give you a greater degree of lift and control over the air around you. However, that's highly complicated, and you know, I'm sure they wouldn't pay for that. Yeah, that's standard. Well, it's the best kind of design, technically speaking. It's like an accelerate air through, I can cool it. That's a whole thing. Anyways, point is, turns out this shape's still really, really good, and I don't need testicles. I kind of do, actually. Unfortunately, I actually do need a bit of a cleft for this to work as efficiently as possible. It's just, yeah, mushroom tip, but that's like canards, effectively. They're always annoying, though, about that. Yeah. Really? Well, not the aerodynamicists. It's just the people that keep going, well, it looks very like a fucking penis. I'm like, well, you know, shut up over there. It's a very efficient shape. It needs to travel efficiently. Can't even try after a while because it's like it genuinely is. You know, I need to keep the nose pointed up. Okay, I need to be able to make that mushroom tip be a control surface. I need to be able to absorb a little bit of that air towards this, from the front in towards the center, and then that allows for the rear to kind of be more of a balloon. But then it's like, well, I mean. If you're going to put in the gas and fuel, why wouldn't you put it somewhere else? Of course. Well, I suppose I'll just put you into the front instead of the balls and testicles. That's fair. Well, wait. Why would I want to be at the penis, head, and tip? Of course. Well, you'll be seeing yourself blast off that direction, that's for sure. So it acts a little better for aerodynamics. Again, actually, technically, not really, but slightly yes. It's a real catch-22 here, because then it's like I can widen that a little bit, and then I can get a way better lifting body front end and control surfaces for that matter. Okay, because it's wider. That's more of that teardrop shape I'm looking for. Okay, I have a longer duration, effectively, of how I can get it to perform its given combustion and burn cycle. Okay. And resultively, as it travels down the long tube it has to go through, right, that allows for me to capture a decent degree of energy and set up for more of the, required neutron plasma I'm hoping to break apart and turn into actual thrust. Now, the problem is it means that I'm looking like a person that's that's effectively ejaculating to get into space, okay? So now the arguments are what they are, and of course it is still going to need that rear pitch and yaw control cleft. Right, no, it is efficient for what it's worth. See what I mean? I just don't personally prefer it. I'm more of the guy that likes the tip going that direction more than anything in towards the front. But, Far be it from me, because that's a lot of fuel towards the front, and I'm not a big fan of that. You know, even if I have to put a lot of you into the tip, I'm just not a big fan. Especially when I'd rather like it just not be made that way to begin with. I'm like, no, could we not do the fucking penis joke anymore? I don't want to do this. It's not a joke. You're gonna do this. He's the guy paying. It's the investor. It's fair. More penis, and gonna have to determine whether or not we want it to be a dual thrusting, both front, port, and aft, or whatever version it is, right? And or just the one direction. Which I suppose I could have it enter towards the center and then be diverted one way or another, or possibly snake, and then come out one way or another. And I can clear up the center and close that off and give myself a little bit more room. Yes, no, I already hear it. Well, why isn't it going into the vaginas? And wouldn't that give you so much more room? Yes, no, the ovaries are firing on all cylinders these days. That they would work. I don't disagree. It's just the problem of it looks silly, and I want it to be professional and serious. And you are not doing this. I'm just saying. I'd prefer it to be a little serious. A little more, please. It will work, though. Oh, well, I'm not saying it won't. In any aspect, actually. At all. It does kind of seem weird where I put, like, everything. I'm just going to move on. Because I'm done with that. The point was that I made a type of polystructural polymerized skin that is very stiff to begin with, but because it can now accordion on a micron to nano size, that then intersects itself and allows for both bending, torsional strength, but is extraordinarily light and incredibly low reactivity under many high heats and pressures. But fortunately, but this is by design, it does biodegrade for good reason, because fuck you, you PTFE forever chemical garbage people. I'm going to get you into space. I don't want you polluting everything already. Just saying, man. It's a bit of a thing. Yeah. Now, that was the reason why I made it a reverse, though. Like this is fine if I have it just coming out one side. You know what I mean? Because it's like, well, that's, really more than anything, just like a ring kind of style that I can connect towards that center as I close it up in space. And then I get a big, huge, massive one, right? And it doesn't matter if it's front or rear. It all works out. You know what I mean? Granted, the front's a lot smaller than the rear for all it's worth, but you also get a lot more space, which is wonderful, and you're going to want that, yeah. Versus, I have a big ball, and say, I don't really want to do Death Stars today. I have to do my space 3D printer to make a Death Star, man. I can put this on the ground, I can get it to that point. Like, if I want to make a fucking size of any of that, I have to get it much larger. And I do have space 3D printers, granted. That's a standard, well, here's a plate that you start with. You create the type of electrostatic powder coaty kind of thing. You fire it with a bit of a particle linear accelerator style design. You zap it with some light and electron juice the right way, an electromagnetic field to kind of use that sort of tube TV style design. Then you can fire it as a single standard nano-size particle to elemental and build from there. You can get it to be even plasma depositional if you want to heat up those element / and or nano particles, right? Which sometimes you do. You might want that. And when you deposit it, it's just the right electromagnetic field on both near the substrate, but also from the gun it fires. Now, granted, of course, that's a given type of thrust, right? So usually that means that they are working in tandem, we'll say. The plate substrate that's free floating and the electromagnetic attractive force that attracts the gun back to the plate as you fire it. Now, it's all a bunch of sequence of events that has to happen properly. But what you end up getting, unfortunately, well, yes, it does attract itself, the gun, the head, the printer head. Well, this starts spinning. The plate, right? So, you can't stop the plate from spinning, so you actually use the plate spinning to your advantage. Now, the faster it spins, the more quickly you have to do this. And so, standard, typical, well, I'll just point it in the other direction, slowly start to turn it from spinning the neutron style 25% the speed of light to, oh my god, this is a pedestrian walk. At best, if I was an old cranky dick fuck that couldn't walk anymore. I've got less than 1 mile an hour. Tick it, tick it, tick it, tick it, tick it. But luckily, because we're talking about a very, 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 very small amount of something, it doesn't really impact it that much to the given mass. Now, as we're adding more and more mass, of course, we're also getting more and more resistivity, right? That means we can usually build from a single plate. That's all you really ever usually need. However, the problem is, of course, you have to do the thing, and that usually means, oh my god, look at this nice buoyant craft that can just yeet something up to there and fire it. Like, I'm just going to continue doing more bajooing over here. Look at my Death Star. Hey guys, do you see my Death Star? Stop. Get over here, you dick. No. It's fine. You don't even see that side of the moon anyways. You don't even need these other asteroids and comets that come by every so often. Shut up. Stop. It's fine. It's just this mountain I bought. It's a whole land. How did you fucking what? Minerals, Marie, they're minerals. This mountain is not allowed to go into space. Try and stop me. I bought this whole land. You can't stop me. I'm allowed to go to the fucking mantle. Suck it. No. I am allowed to. I didn't say I'm going to or could. I just said I'm allowed to. You stop doing. Stop doing that. No. I shall now extract more minerals from my mantle that I own in this small spot. This is not allowed. Could you stop it? No, I'm not going to. I powered with the geothermal, of course. Obviously, I create a nice square round thingy-majig, which isn't really quite technically what that case is, but it does. It creates a nice triangle to a roundy arch shape that then intersects like a Star of David almost, but reverse style. And a multitude of these things later, I then get a very strong supportive structure that, of course, has a great amount of surface area that then allows for me to do this wonderful, cool thing called putting water down and boiling it. I do the boil so well. I'm so good at boiling. Look how good I can boil things. Ain't no one boils as well as I can. This guy right here. I got piezoelectrics in there. I got thermal photovoltaic. I got thermoelectric. I got steam turbines that are not even possibly trying to move. Except they undulate, they still move, but you know. That's what it is. Less moving parts, it rains back down, the whole process starts again as it collects in a nice basin, and it goes, whee! bumpy and makes like the undulational 90% capture of all that. As I get more and more heat, but of course that's initial heat versus the later heat. Of course, as it cools off and then it has to rebuild the heat. Whole thing with heat batteries. Whole thing. There's a consistent amount of heat at all times. Bullshit. I cooled that shit off. There ain't no way. There's a thermal transfer. A certain amount of thermal transfer no matter fucking what. Don't even try. Meanwhile, it's sealed on the outside. It's not just ground around there. It's just like, yes, look at me. I'm super cool. I got this polycrystalline diamond and more. And it's all like, I'm not even going to burn. Shut up over there. I'm going to do so many cool things with my cool energy. Like suck up large amounts of lava. With my ceramic that survives it. With polycrystalline diamond embedded inside. Which definitely happens to thermally expand to the correct amount, so that way I get all of the pumpy wumpies going. With the undulationals. It cools it off somewhat, but not much. Alright, actually I have to try and turn it into a plasma. Since there's so much electricity, which is kind of a problem, and if I turn it into a plasma, it allows me to separate all of the elements I can try and extract from this shit. And I have more than enough electricity to do it, so I go, you know, it's still pretty hot. Bonjour! Bueno! Yes, muy. Look at me. I'm both French somehow and fucking Mexican. That's a reference to certain things. You wouldn't understand, but if you do, nice. You're smart. Those are certain people that have been looking into technology for hydrothermal for a very long time. And geothermal, for that matter. So it's good stuff. Anyways, this allows for one of the best things possible. I can now plasma deposit as necessary, electroplate as necessary, and effectively get the vast majority of that plasma and that heat back as electricity. Over a very long period of time and process. Look at me, I'm just printing huge mother god, what? Yeah, I wasn't gonna stop. Look, it's going further up with my buoyant activations of many ships. It's standing tall and proud. It's supported by the very air itself. Look at it, plasma shooting into the spacies as it sucks it up with the nice electromagnetes and electrostates as I'm making ever larger and larger, grander amounts of this Death Star. This fucker. It's getting bigger. It passes by, it goes, splash me, daddy. Oh! It builds up. Ah! It's getting hit facially, you know, whole thing. Anyways, long and the short of it is, it's doing some of that. Not really. I wouldn't probably do that. I would like to, though, because for what it's worth, the plasma moving then creates a counter force. And then that counter force, both attractively and repulsively, keeps it stable versus all the air around it. The longer and longer it gets with the buoyant supports, the greater and greater chance it has of surviving. Standard stuff. Now, the problem, of course, is this is whizzing by really fast, and I don't want to do that. It's scary. As much as I'm like, you know, pound me and all that, and facials and so on, it's just not a thing. It's pretty not, like, as easy, but you know what it does do? It means I can siphon into, more often than not, both the substrate as an initial, like, electromagnetic, as I set that up and it lands, but also I can siphon that into the very gun and the reservoir and cool it and or just deposit it as necessary, which is good. That personally I tend to do because that's usually an easier way to get it done faster and safely and ultimately have a Death Star that is the equivalent mass of our fucking moon. No, I can't. I want to. I wanted to so bad. I was like, how much? Oh, it's a fucking 6 of our gravity. No, I'm not taking that. If you're like, what are you doing over there? What are you doing? Earthquakes are everywhere. What happened to the lava? What is going on? There's a collapse of every tectonic plate around us. What is happening? Look at the cool stuff. So, I made it bigger though. He's not as cool as us. Yeah, it's a thing, right? Because like I definitely have to help me with that one. It's an idea though. It's an idea. Not a really good one, but it's an idea. And that's why I said, oh, look at the moon. You don't even see that side either. Okay. We like the moon's mass as it is. Yes, but what about, like, you can't stop me? No, I could totally do. Somebody stop this guy. Mercury, how's it been? No, stop doing. Mercury's always getting eaten. We all say that for what it's worth. You know, in science and physics, it's like, no, Mercury would always have to be eaten for something. But that's why it's like some of the back of the moon. And it's very smooth now. It's very smooth, the moon, obviously. We need the moon to be very smooth, quite incredibly, wonderfully reflective in all the right ways. So that way it always reflects. Don't do this. So if you had a powerful enough projector, you could use the moon. Otherwise known as the mirror. Very constructively interfering the right, shapes, the right triangles, all that, and mirror, and then it can, Well, it should be fine though. Some crystals there, it goes a little bit further and it bounces off in the right places. Anyways, it all, tends to equal out instead of like a nice concentrated Archimedes death ray. Instead, we just get a nice, wonderfully straight-ish, somewhat starts to fuse out. So it has to be slightly, inward, and then because it has to be kind of focused, and then it has to slowly spread out. Because otherwise, it doesn't work. There's that. But now it does. Go fuck yourself, Dick. You didn't know the moon's distance changes? Yes. Which is lovely because it's set up for that. Except for the rear. You didn't know. It's quite smooth. I needed extra material anyways from the moon. So a side that faces us, it's just a good idea to do it. Except for the fact that I definitely did carve pretty deep in this fucker. It needed to be balanced. I don't want it to start spinning or anything weird. Come off. It's a whole shape with a parabola, and there's parabolic and this little spiky thing, and then some of these little channels and grooves and overhangs and tubercle, blah, blah, blah. Point is, it's a bunch of waveguides that essentially turn the interference of that light into a very good, constructive, consistent, straight. However, I'm trying to make it effectively push itself towards the Earth. Because what that means is it can't really do that. FYI, there's no solar cell that will do that because it's too damn heavy. And there's a lot of gravity. Gravity wins out, right? But what it does mean is that now it won't spin. Because the mass has massively changed. So I use the solar cell as essentially a way to force it to no longer have this issue of where you'd have to be concerned. Which is good. And also, before it was slowly leaving where it is positioned, and now it will never do that. It'll always be exactly that distance, consistently, more or less. Hypothetically, we'll see in a couple of 10 million years or something. Or 10,000 at the very least. So I'm going to leave it alone. Because, that's a big constructive engineering project, and no one's going to be able to stop me. Are you kidding me? Try me. Venus is my bitch. That atmosphere is so good for extra heat and more. Mercury needed a nice little gas station in between it. You know what I mean? No! Stop fucking taking our planets. You said there were comets and a fucking asteroid. Ceres was gone. I wouldn't even look at Ceres anymore. For that matter. That bitch is over. Please stop. What's up, moon? On Mars? You're not on it. That's good. Ain't nothing stopping me. That's me. Now, granted, that's just because I wanted it to be genuinely, actually, the same mass as the moon. I then was all like, but wait, I could make it more massive. So I then proceeded to do a slight change in recalculation, because I still had some Mercury left, and Venus was just lower in atmosphere. There's only a couple moons that, decided to leave. There's such a nice white cue ball up there. It's frighteningly bright. Full moon. God, it's just constantly twilight over here. Yes, I tried to get it as good and as close to the entire roundness of the Earth. Now, granted, it slightly curves in, so there's a given distance and degree that they can't really work, of course. Right, so, I try my best. But, certain places is quite a bit brighter. During the full moon. And I shouldn't. It's the fucking noontime, bro. Yeah, almost. Almost. It's more like a for it. Like, this bitch fucker. I created a new natural wonder. I don't see what the problem is. You'll travel to these places specifically to make it so that way you have daytime during the nighttime. And it's lovely. It changes depending on where it is. In the year, Arizona gets a lovely, because I'm in Arizona, bright, terrible amount of light during full moons. It's basically just day. It's not as bad as some other places, which is genuinely like for these fuckers. But luckily, you can still see the stars. Wonderful for telescope enthusiasts, I'm just saying. I'm going to move on. Yeah. Disrupting natural environments like humans tend to do. Whee! It's not that bad. It's only noon and... Oh, you have to be in the Pacific Ocean for that one. Yeah, well, that's a very specific point in time, too. The phytoplankton love it, though. They've been really enjoying that, for what it's worth. And the algae, for that matter. Got a lot more oxygen, I say. Could all use a little bit more. Is there anything else? Oh, yes, tidal waves are not quite the same for what it is worth. Storm surges are different, though. Because there's less of a tidal force to help out with that, as the balancer usually tends to be, Just brighter all around. This fucking sucks. Yes, I tried to split it between, three kind of sections that would blend together. Northern hemisphere, equator, and then southern hemisphere stuff, right? But, of course, at different stages of rotation and lunar cycles and, at different points during our orbit, all of that changes. So it has to be a very, very, very specific shape and surface here that I had to make specifically for this, which I had to do anyways because I wanted all that material. So it worked out in the end. For you, baby. The new moon is nice. Oh, yes, that crescent's a bitch. Fuck you. Half moon. Oh, my goodness. This is lovely this time of fucking day. Isn't it? It's past midnight. Honey, come on. Fuck off. You know, the moon's visible during the day. Sure is. That's for sure. Sure is. That white glowing orb that you'd think is the second sun. That fucker. It's lovely all the time. You'll never miss it. The face is wonderful. Now, granted, if you do happen to have a good projector, which is several satellites and Lagrange point satellites and satellites at the moon, and lasers based upon us on Earth, then you can 100% make a good projector that will 100% constructively interfere with natural light back towards us. And it'll create band frequencies that are wonderfully positioned for the equator that blend constructively in between. For the northern hemisphere, the southern hemisphere, and the equator combined, this is where it's directed, and then it blends as it diffuses outwards. And a constructive interference. Blanketing basically the entire thing very, very, very effectively and efficiently. It would be a shame, winkety winkety, if somebody were to use this as a reflective type of satellite internet. With light, perhaps. I wouldn't know anything about that because I certainly didn't do a fuck ton of work to literally make sure you could do that. With radio waves and microwaves and IR. Like a ton of different electromagnetic frequencies. They never really tried, though. Really? It was a bit of an annoying thing. You know, it's this thing that if you know what you're doing, it's always there as this phasor array dish that you can just use constantly as the main source of all of your programming and calculations, even as it reflects and constructively interferes at different pulsing and blah 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 blahs effectively. That then, of course, get to you as it filters through our atmosphere and you go, antenna, activate. And now I have free internet for all, but they're all like, no, the moon, no. You cannot use radio waves for, fuck, no, don't say that. Look at me, my AM radio is absolutely brand spankingly new, like back all the way in the 80s and 90s, the internet. Can you shut up over there? We don't use those spaces. Anyways, point is I'm deflecting quite clearly because, yeah, I kind of carved a lot of Martian surface to get my way. So I had one hole of the Earth's gravitational fucking goddamn G so I could then yeet myself out of orbit around the star and travel anywhere. As I was all like, behold, Europa Titan, you are now my bitch. Sucky, sucky, sucky. Oh yeah, give me all that fucking water, bitch. I want more of your core juices. Give it to me. There are a lot of things with Jupiter and Saturn and Neptune and Uranus that had a lot of hydrogen that I stole and took, and they can't stop me. What are you going to do about it? Ain't no one going to defend you. Suck it. I was whizzing around doing this for a couple of decades. You know, standard stuff. I was all like, what's up, hot star? How you been? Baby. Oh, man, I want you so bad, but you're like way too hot. So instead, I'm just going to use you to light some of my fires over here. as I zoom and enhance with my wonderful mirrors and lenses into a core of epic proportions and heat it up. As I pass dangerously close with tidal forces galore. Oh my gosh. Inertial confinement fusion. Oh. Look at the heat and pressure I can get as I move it in a linear fashion around a toroidal structure towards the center in a big crashing-like manner, like convection currents towards a core, while I heat it massively during this as well, and force it to go even harder at itself. Those stupid tidal forces, as I spin, it allows for it to collapse towards the center and stay together. This is something I want, usually. Sometimes I don't want that, actually. Standard, hey, God, what am I doing? This sounds dangerous. And they're like, no, I'm all in you. We all think it'll be great, until you have a fusion bomb that's really way too fucking much. You know what I mean? Insane. So anyways, I was all like, yeah, but it's sustaining itself. And then I was all like, what's up, Earth? And the Death Star, of course, did not have any luck in killing the Earth, as it is not named the Death Star. Someone else named their fucking ship the Death Star. Kudos. So there's that. But I did not aim anything really technically at the Earth. Really, all I technically really did here was use the reflective area off the moon in its rear to allow for me to start accelerating without harming the Earth. However, that did mean that the moon got a brand new atmosphere and it got quite hot, and I dumped a just massive amount of mass onto it. At nearly the speed of light. Standard stuff. Like good old thermonuclear ball. Whee! Oh, God. It was super fun. I got to 3 Gs of acceleration for a whole fucking light year, bro. I got a whole year of 3 Gs. It's a good thing I was spinning it. I mean, I always got to fall down. But there's no. What's the trick here? I want to know what that trick would be. So, here's the thing. I have 1 whole G, right, of a planet, right? Except, technically, I don't anymore, because I lost all that mass. And then I got it up to 3 Gs of acceleration, except I lost the mass, right? Right, and of course I'm going to slow down because I had 1 big old spurt to really kind of do it with. So if I spin it the right way, as you're apt to do, with the big old terrariums, and still somewhat decently, still quite hot core here as a heat battery, I then get this never-ending falling effect, as that all depends heavily on how it is you rotate a rotating oval gear. Let's say it was an oval gear, but it's kind of like a belt. As the belt rotates, then it rotates on the inside and it falls back inwards. Now, the only way this works, however, is if you do it very carefully, as it needs to rotate around a fucking goddamn sphere, very specifically to never technically ever have 3 Gs. You always have 1 G at all times. A very tricky piece of kit, I'll tell you. Except every so often, you kind of need to not be falling. Right? So you kind of have to go, and then I'm back to normal. Now, luckily, that takes about a whole year. Which is nice. Nice good old clock, so to speak. Like a turbulornians of sorts. Now, from 1G, right, it went down to half a G, which sucks, actually. For what it's worth, yeah. It's not super fun. But, what it did mean is that acceleration and that force was then transferred to a acceleratory opposing force of that spin. Right, and that's the captured, and then I get to create a magnetosphere and atmosphere, which is lovely. Now I don't have like a star, but what I do have is the equivalent of effectively a stupendous amount of heat and stored energy potential from all of that. That's a bunch of mass that's now rotating very, very efficiently. That has to do a bunch of electromagnetic fieldy wildies and blah blah blahs, and then it slowly slows down. But because I'm traveling quite quickly at 3Gs, but not realistically, however, I do get that good old-fashioned blue shift, which is still light. And I have the neutrons, which gives me a nice good old fissile kind of effect. How do you continuously accelerate after if I'm spinning? Yes, well, neutrons tend to help, but, the heat has to go somewhere. So, every so often, I have to re-up, but I do slowly slow down. As I will eventually get only to 1G of acceleration. I got 3Gs for a whole light year. But eventually it'll go down to 1G of constant acceleration. Shucks. That's going to be in a few billion light years, so I don't have to care. Such is the way, right? Balance is all things should be, right? Yeah, standard. I started from here at the bottom, working with some fucking dirt. I then worked really hard to turn that dirt into something good. I then got it to float the dirt. I then turned the floating dirt into another floating orbiting dirt. I then used other dirts, and then I got an even better dirt that floats. I then floated that dirt closer to a very big pile of dirt that got quite heavy and hot for some fucking reason. I then managed to use this heat and gravitational influence because it's so fucking hot and heavy and big. It's massive. Holy fuck. You ever been close to the sun? You probably haven't. Well, I have. Suck it. Which, by the way, remember the whole, reverse thing that the engine, that's what I'm talking about? Yeah? Yeah, that's like a bearing. A magnetohydrodynamic bearing. They both can rest on a type of surface fluid. And extraordinarily low friction, like a superfluid in a sense, like a quark gluon plasma, except I can make quark gluon plasma, but, I can make pretty decently good fluidic plasma that I can control fairly well between these two structures, and they even happen to give me a great amount of density and protection against many things as I accelerate all around. Which, yes, while it does seem a bit odd, I also get this core and all these other things that collect it, and, so that's why it's always just spinning and continuing to collect more and so on. Of course, it is a big mass here. So, as a result, I can't really quite do that. Standard stuff, basically. That problem of, eventually it's going to slow down, So I'm swinging over to this place called the Sagittarius Star. But I need to go do a nice little hooky maneuver by this Sirius guy. It's already been 3 light years of 3G acceleration. So I figured I'd probably get there soon. Yeah, standard stuff. Sure, it's all about starting with the dirt you've got and getting a whole bunch of people that believe in you and will help you put it together, and all of that working collaboratory and leaves being exchanged for resources of other sites and sizes, have values of other leaves and pebbles and so on. Which then eventually gets you to this point where you now have floating stuff because physics, and it's just refined rocky rocks and dirt put together. That was napped really, really, really well. Real stone knocking on stone stuff. When done properly, it then gets you to this point where now you're yeeting yourself across space. Why didn't I ever think about a turbulence? Yeah, I know, right? Would have worked too if you'd ever thought about it, but hey, that's you. It's no biggie deal, truthfully speaking, because honestly, I wanted to get there without having to have a type of particle acceleration, detonation, fusion moment problem. So I eventually created a different version altogether of the faster than light inertial acceleration designs, which just sort of create more of a vacuum in front of you. And then, because you're accelerating so quickly, it then allows for you to sort of move an electron the right way to tunnel it and so on. So space and time kind of curves as it's apt to do as mass tends to move around. And you do it for the skin and then goes through the right way and kind of like gets sort of very smoothly and then elongated. So it's like super fluid, and then it's getting elongated, and then it like pops, and then it's exactly the same place and exactly the same amount of acceleration, exactly all these things that allows for you to then be on the other side of that. And you get a little bit of energy from that. And of course, the energy you have to put in gets you something, right? Okay. But it's remarkably less energy than what it is I'm using to make this. So I made this specifically to get up to that speed. 3 light years is nice, but I want to go superclusters away. So, supercluster, away we go. We're going into uncharted territory. We don't even know what the fuck's over there except a bunch of pricky galaxies. Woo-hoo! Because once we get to the right speed, which is usually in the 30 to 60% the speed of light, but the faster you start it at, the more efficient it is to start. So if you're already at the 90% the speed of light, it gets massively, massively much easier. It takes a fucking like AA battery to get you to go faster than light. But that's because you're already traveling with significant space-time curvature. Standard stuff. Hey, I already put in the work, so it's like, oh, well, geez, holy fuck, wow, did you ever? Whee! That old thing. But it's operating off of thermodynamics, quantum thermodynamic, and interference wave functions collapsing in various ways that are correctly ordered and kinetic to collapse elsewhere in a very Invotani type of way. Decoherence. I am now becoming more apt to be seen by all of this other stuff around. Versus I was not. I was quite secluded and exclusive and private in my affairs with this. You can't know about us. Love it though, right? But of course, that's, instead of superposition, because I can't really do superposition, it'd be really cool, but you need to be a lot colder than that. So instead, it's more about the fact that I'm moving something correctly to effectively alter that given type of reaction of space and time, curvature, diffraction, reflection, lensing, that kind of thing. Yeah. If you do it the right way, it turns out it does do this wonderfully, but it creates a reverse fisheye in the rear. The front, it looks like it's just black. You're not going to see anything. And the sides, you basically see some like sparkle stuff. It's not much. In the rear, you see a big fisheye lens, kind of like what we theorized would be in a black hole. But for what it's worth, we're not in a black hole. So that we're not expanding space and time. We're just moving it in a different way, away. So that way there's less of that there. Which means we're not expanding it. Yeah. Yeah, it's more like making it less dense. Like we're sucking it out of the way effectively in a very controlled manner. Because it's a lot harder to move space and time such that I expand it outwards in front of me. It's really hard to do. Instead, I'm just like, you know what? Fuck you. Let's just go this way. Let's just do this very cleanly now. We're all going to get along, space and time. We're going to get along now. Orderly now. Yeah, I'm watching you. So, however, that would be the final thing. So I'd be testing that while I'm going to try and start up my good, I'm going to genuinely have a big thermonuclear bomb go off for my core for a while as I try and build up heat and pressure. As more mass is necessary and I have to capture a lot more of that neutron stuff. And it gets a lot more difficult to fire mass towards something without effectively having mass kind of thing. It's one of those, you can't make mass, can't make bosons. You have to just grab things that already have them, because otherwise you have to get into Big Bang stuff. It's a lot more difficult. So, you know what? There's probably enough around here. I'll just grab that and collect it for a while. Meanwhile, I still have half a G worth of matter. I never got to the moon. Shockingly, right? It's like, oh my God, I got up to 1 G. Yeah. Yeah, that core was quite dense, I'll tell you. And that moon sure took half a G of the material of Earth of a hit at near light speed. Yes, luckily I was far enough away that I'm not going to have any problems. It'll never hit me. And it's shaped very wonderfully to capture the vast majority of that and interfere with the plasma such that it effectively causes it to do the version of a Peltier or turbine or whatever it is. Curves it around and then it fires it back because, of course, there's gravity. So good old gravity bullshit. Yes, well, anything that was on the moon is certainly not probably super happy. It's about to get literally half of Earth's worth of material on it. Although it'll take its time to do that. The standard, at first, it's about 2 of Earth's actual worth of material, in G of mass. But the rest will show up pretty quickly. By that point, she'll be raining down and there should be a bit of an atmosphere, as it's apt to do. Now, I don't know if they ever used the projector screen, but, it's not going to really be there anymore. But man, does that core really pop off, as it were, right? It's quite hot, getting blasted in the face. There's probably some gamma rays, I imagine. There's a mantle forming for some reason. The whole surface is basically magma, right? It's probably a lot of thermonuclear fusion as it's accelerated with a 0.2 of Earth's worth of mass here. You fucking know. Yes, well, it's quite heavy matter. It's the best matter to fire at first. The heaviest matter, right? It'll get hydrogen at the end. It's going to be fine, okay? It's just, what did you say? Very stabilized matter, element, and whatever chemical compounds come from that. Why? Because whatever I can do to stabilize that, which means I don't need to worry about radioactivity or neutron aggregation or any of that, is a good thing. So that's what I'll be firing all the way up to UUQ, otherwise known as limkeonium, because it's the stabilized version of UUQ. The only one. It's called limkeonium. That's right. It exists up there on the moon in large quantities. Massive amounts. Actually, there's another one on the hydrogen side and one slightly past that. So good luck for getting that. I really doubt you will, though, for what it's worth. Really, because it will take a remarkably long period of time for it to cool off. We're talking, it's melted. The surface is melted, bro. The core has been restarted. There's a mantle. Tectonic plates have for sure become a thing. And the little bowl that I made that is really quite cool has now been filled and turned into a massive, massive plasma lake cooling off to a big lava pool. What about that opposing equal opposite force? Did it happen to... Oh, well, you know. It's certainly more of a circularized orbit, as it is, of course, is going to spin in a 24-hour cycle. Although it won't do that perfectly. And, of course, I do have to aim this wonderfully so that way I don't hit you. So I'm doing that, specifically in a nice pattern. Yes, you thought I just yeeted out of the solar system immediately. I cannot do that. Are you for real, man? There's no way. So I had to come back, and I had to shoot my load again, and do a flyby fucking facial again. A flyby, like, just injection at that point, because, you know, that's cracking the surface, man. It's just digging in there. It's getting in there. So, as a result, now we have a lot of good volcanic activity and more on the moon. But the very final flyby is effectively all of the lightest material. It goes all the way down to hydrogen. I then fired the last of the hydrogen with a little bit of oxygen. Why? Because it's H2O, baby, and you know that. It's going to cool it. It's enough to make, genuinely, because it's another half a G here, the orbit of a second Earth occur, a binary system. As I flew away, I left it better in shape than where I found it. A bit of a good rule to follow, you know? Now, it will take quite a bit of time, of course, for it to cool off enough. You know, we're talking 10,000 years of never-ending rain. We'll see, though, because for what I calculated, by this point, the atmosphere will have massively cooled it off, and because there's a bit of a ring atmosphere now that it's flying into, it has to do that. It's changing a degree of its gravitational momentum and changing some of its spin. It's still on a 24, wonderfully, but now it's a properly stabilized orbit. While the rest of it rains back down on Earth, the rest of it also rains back down on Earth too. Now, the orbit is wonderful because it also helps with this little Goldilocks zone problem that Earth currently has, where we don't want it to be a little bit too much further, and we certainly don't want it to be a little bit too much closer. So it's now making it stable. However, you are in a lockstep. By the time the sun is about ready to explode, guess what? Your Earths will likely be close enough at that point for you to genuinely start feeling the effects of tidal forces between the two. A binary is something that works that way, but you can now live on Earth, which is good. It's a little bit further away, a little bit more centralized, we'll say. Less eccentric. Better for what it's worth for weather. Both of you will protect each other. What one loses will go into the other, and what the other loses over time will go into the other again. You always maintain a degree of a decent atmosphere. Your two rotating mass bodies of magnetosphere will collectively keep themselves going for a very long period of time. Wonderfully, right? You'll have a degree of a atmosphere that exists in between a Lagrange point, unlike before. And when charged particles come by, well, they'll go to that Lagrange point and yank it back to both of those planets. You'll never lose any more helium, practically. You should lose a little, but it's very little now. Same thing with hydrogen, which is great. There's always a catch. Well, you'll be a little bit lighter sometimes. Yeah, your orbit's quite a bit differently circularized. You see, you still have, the seasons, right? That's both tilt and distance from sun, right? Well, this also changes based upon your orbit and the binary too. So luckily, that means you still get your seasons as per usual. And in fact, they basically follow the same pattern, which is nice. It's just a little bit more stable, a little less intense. The charged particles are a bit rough. You're going to have very rough as fuck storms for a long time. How rough? Too rough for what it's worth. Luckily, nothing you can't really handle. We're talking about massive thunder and rainstorms and lightning galore for a while. And then, that's basically it because, hey, guess what? You now have a much easier time getting to Earth, too, than you ever did the moon. You saw some crazy lunatic create a reverse bell-end aerospike engine who then yeeted a fucking planet with a turbulence-style faster-than-light drive over time towards Sirius B. Geoengineering and terraforming a planet that orbits your ass to give you a 24-hour cycle, fucking binary, second place to live. Something that you can only dream of, as apparently you never have enough space and other bullshit somehow. But what it does is it means, well, global warming is going to take a big hit. See, a large amount of albedo factor is going to go up, and carbon dioxide is going to have to go somewhere. Carbon dioxide does not like to exist in massive amounts of lightning storms and charge differences. With a high degree of increased charged particle areas in those magnetospheres. Which means you have a higher degree of constructively interfered X-rays that turn into a gamma ray that then like to turn back into a bunch of ultraviolet and blue. You get more blue light, basically. The green that you used to see has been filtered. You have a far more actually corrected light. It's not all green like before, and then we filter that out. A lot of things are about to look very strange for you. And a lot of carbon dioxide is going to be ripped apart. Carbon's going to come back as a bunch of graphite and graphene and nanoparticles and onion balls. Stuff like that. Which normally isn't so bad. But it wouldn't be that bad. No, it's not going to be that bad. It just means everybody's going to be grounded. Nobody can get the hell off the planet because you're going to have a huge, massive thermosphere events that are now going to act like they're at the top of Mount Everest. That's where the atmosphere happened to go. Now, it doesn't really bode well for the vast majority of people on the ground when it's like that, right? Because, of course, hey, you fucking and terraformed a planet. And so, like, as gentle as you can, it's still not going to change that it's going to be around, causing some problems. Best I can do. However, if you were so inclined to try and live a long, healthy life out of our atmosphere, you could do this. And you'd probably fare a little better for certain things. And the other benefit is you get to watch two beautiful planets in your Lagrange area, where you have more than enough light, more than enough material for what it's worth to keep it going for a really, really, really long time, which is pretty cool. And over enough period of time, you'll see second Earth cool off. Now, this one's more around the 200-year mark. But you'd be able to set foot on the planet before that. Now, these are the poles, versus the equator. But you'd be able to do it. And you'd be able to start the first true type of panspermia event ever, if you so chose to. But be warned, it is cooling and there are tectonic plates. Not exactly as easy as we just, we put some stuff there and it happened. So, the standard. But 200 years is for the equator, as well, if you were going to do things the right way. Point is, it wouldn't matter. I'm just trying to get you into the ballpark of where things are likely to be. If you wanted to live there, so be it. If you don't, you don't have to. All right, you're just going to have to deal with the fact that now you have a second Earth binary that makes your gravitational influence be in a weird Lagrange point. Your gravity for Earth is still inside of Earth, which is nice. However, you do have a Lagrange point, which is like a third body compared to both of you. Because you both orbit around. It's a whole thing. Yeah. Cool stuff, though. Beautiful. But you have to leave it at that. Are you going to live for 200 years? I mean, I worked on longevity stuff. It's all in my biohacking playlist for what it's worth. For a reason. I didn't just want to travel really far, really fast. I wanted to live for a really long time. And I wanted to survive through any kind of hardship. I wanted beyond a type of biological mortality that science fiction writers can only sum up as quantum bullshit and magic. The best kind of proof. Hey, what's up, Kyle Hill? The magic proofs, But I did manage to get pretty far with that. And beyond even a singular cell, I can build you. It'll rebuild that. Yeah. And you'll remember everything for its worth. However, that'll take an exceedingly long period of time. So what I do is make it so it's very unlikely for you to ever be damaged or hurt by anything. That kind of thing. That's what that would be. But that took a long time to get towards. So instead, it would be more like, at first, it's just good biological immortality. Hey. And let's just not hurt myself while I'm in my cool spaceship with others. As we travel towards Sagittarius A star, what are we doing over there? It's going to be a superhighway. So, the whole opening, like the vacuum thing, right? Well, then that actually helps with moving and curving space and time. It just gets a little bit more intense. You have to do it a little bit better. But of course, as we get towards another star and other mass, as we travel faster, then we get better at doing it. Before we ever go anywhere near there, we're hoping very much, more than anything, to know enough of that. Now, granted, I can get super clusters anyways. I just have to pour more energy into it. I don't really want to do that. So instead I was thinking, well, what if I went towards this? The black hole? Yeah, we're going right through it. Why? What are we fucking, what? Yes. Well, it works though. Are you going to be able to see what's in there? Doubtful. Really, it's extraordinarily doubtful. It's one of those age-old problems. Just because there's a fisheye lens behind you doesn't mean things aren't passing by it exceedingly fast. Even with the best camera technology I could ever have, it's still very fast. So, a single frame would be nothing. It's one of the reasons why I developed something that's more analogistic. For any amount of change, it measures that. Kind of like a scratch on a vinyl record. Right? But I then had to learn how to compress that in, many different ways of encryption and breakout algorithms. And patterns and sequences and dimensions and multiple matrices that all have to move in a proper pattern and sequence, and then layering that again in multiple different ways. Whole thing. Big old encryption thing, basically, that is highly compressed and very, very, very dynamically random. So it's essentially impossible to ever actually view it. And that's only because, there's a computer. So if it ever gets used on another computer, it will never work. That problem, So, that's what I did for that, because I still need to learn how to navigate, and I still need to know what the hell is going on, and I still need to, kind of curve that a little bit better so I can maybe see what the fuck I'm doing moving forward. That kind of problem. So I was like, all right, I'm going to start doing that. So I started doing that kind of a thing in terms of, how the hell would you do it, right? And that's kind of what that would be. That's the plan to get towards the Sagittarius A star, the black hole that we orbit, the supermassive black hole, and then use that to supercluster hop. It'd probably get us in the order of about 10,000, but it might get us more. It all depends. Because, I can't hit an infinitely small point. But the closer I can get to it, the greater the distance I can get. My plan is to get outside of the universe, if it does exist. To be the first one to crack the enigma, the code, wrapped in a mystery. Oh my gosh. Is there a, shimmering kind of mirror-like surface that we're looking from underneath some water? Is there an infinite expanse of more stars, thus confirming, at least somewhat, that there could be either an advanced civilization that has continuously made more and more stars in the universe as an omega-level species, just kind of sort of keep us inside of a big ball, I suppose, but maybe they're extra dimension or something. And so now you need to go to a higher dimension to be able to see true ends, even if it is infinite. In the third dimension, it is not infinite in a fourth or other dimensional context, right? Thus, being able to rule for a advanced civilization or a causal set theory. Or is there nothing there? Which means off an infinite amount of distance in any direction, there should very well be another universe. But It's a technicality infinite, as of course it's both expanding infinitely faster than you could ever possibly get to, which is the next stage of my plan. It's to mark all of the boundaries of the universe, and then slowly get to learning how to tunnel really, really far, a technicality infinite distance, to be able to get to another universe. If it were to exist. But now I've got the super cool billions of years of 1G acceleration. And I'm probably going to live that long too. So I've got more than enough time to do it. And wouldn't you know it, there might just be a center to the universe, confirming possibly a Big Bang. At a singularity. And then it all expanded from that point. And then I shall head towards it and be like, this is exactly what happened. And you are wrong. There is a center. Suck it, suck it, suck it. Ha 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 ha. There's always a center. And now I am at the center. Get it? But, for what it's worth, the other age-old adage, we're all at the center, really. If you really were to think about it. It's true. At least currently, until I measure it. No, it'll be a flat expanse. Well, a flat expanse still means that there's a curved cone-like shape somewhere. Yes, it's not a square, that's for sure. You know that. There'll be ripples, of course, that has to happen and exist that way. There's going to be an absolute limit no matter what. Which means no matter what, it came from somewhere that would be the true center. Although it's sort of not like that because, no, this is time we're talking about. This is a holographic. And just delete all of their ideas. Here you go. It's this, actually. What's up? What are you going to say now? What? You don't like that I made it so that way it's impossible for you now to say anything other than, yep, it's that. Yeah, that kind of thing. Just like put an end to all the fucking beer drinking, like fucking posturing talk that scientists and physicists and more like to do. I know more than you. Okay, well, here it is. I went there and just saw instead of going, maybe. I formed a plan so I could go do it. How come you don't want to join me? Let's just go figure it out. Let's go to there and see. Huh? Instead of going, man, maybe it's nice. Maybe I'm right. Maybe you're wrong. Yeah, that's standard. Yeah, I don't like fucking just yelling and trying to prove it with math or something. I'd prefer to just go there. Like, man, this Harvard scientist found all the aliens. We should all believe him. Why don't we just go over there and just go to the aliens, huh? Why don't we just do that? Probably. I mean, it's just, would 10,000 superclusters get you to like another superstar? Kind of like slingshot into a black hole, a supermassive black hole. Or how about another great attractor? I mean, we don't know what the fuck that thing is, for what it's worth. Would it get us into something like that? Wouldn't that be interesting? If we could get that, right? I mean, it's so fucking empty is the problem. But once you get to that kind of speed, it doesn't matter how empty, it's all a white screen. You know what I mean? It only becomes not a white screen because as you travel the depth, it tends to start heading off to one side or the other. That kind of problem. So, how long until you hit something? Granted, the vacuum kind of helps it. You'll go through any real solid material, and from an outsider's perspective, and the observer, right? the reference point looks like you kind of get translucent to transparent, and you kind of slightly expand, right? Now, to anyone else on the inside, it doesn't really look much of anything like that has ever happened. In fact, everything looks normal, except for like this kind of black, more black than you could ever think starts happening. And like some sparkly kind of like, it's not dust. It's, it's like light, but then like we're talking about interference stuff, and you have to interact with that the right way. And you have to have space and time kind of curve properly, which means you have to both skip it off, but also curve that, throwing of a given gravitational wave out, the right way. So that creates a degree of, like we said, gravity creating light in the beginning. Standard stupid people stuff that think they know something. And then they go, no, right, yeah, no, I did remember seeing that paper. Oh, God. And I'm like, they're sparkles, basically. But they're very brief, and they get captured into, like, the direction, like, because that's excess energy we don't want happening to go anywhere else. But, for what it's worth, that's a detector. You know what I mean? Like, I can use that to basically see what's in front and towards the rear and where we are in relation to things, which is a good thing. And then, of course, the fisheye lens kind of weird, curved, everything behind you. It does tend to get you a little bit, right? It's like, this is like a fucking thing. It's like everything. Yeah, because it does. It starts looking very, very ominously like you're pointed away from all of the universe as it curves behind you. And you're like, like on Earth, and you're just like orbiting and like, oh, fuck. Jesus. Yeah, no, scary stuff for what it's worth. It's not that scary. You just can never touch that part. Like, you can touch the sides a little bit. It'll create some issues, but nothing tremendously bad, right? Versus, because I call it a superfluidic engine. We're not warping space and time. Like, technically we're just moving things really well. Electrons in their orbit kind of slowed down here, sped up over there. Nucleus is jiggle wiggle the right way. Space and time curves because we're traveling quite quickly. Anyways, you get the picture. Same thing for that kind of fisheye bowl. So like, the side, same thing. The front, well, we'll never have to worry about the front hitting anything because there's nothing there. However, for this fucker, the rear, it's not like that. If we touch that, it kills us. It would immediately kill us. There is no reverse on this thing. You can never touch that thing. You can curve yourself and go 180 degrees fairly quickly. And you won't even feel it as a 1G, which is pretty nice. But that's the, inertial acceleration thing. Basically you didn't even notice that you accelerated to that and just started doing that, But the difference here is that little, fisheye lens thing is effectively all of the universe's space-time stuff. And you're depositing information as to this, right, existing there as per normal, as per usual. You just siphoned a little disorder and then you added it back in just a little bit as it came back to where it was. And what you're effectively really absorbing is quantum vacuum pressure and acceleration. Okay, the inflatons, I guess. As much as I'm angry about it, there's reasons for that. So I'm going to move on. But that is what you're kind of taking, and it takes a very little amount of energy to do it once you get to that speed and energy already occurring, okay? But the flip side is like, that fucker will kill you and murder you. You will explode and never be able to get back into space and time. You effectively decoherent and exist in a very real tunneled to foam capacity. Constituent stuff, basically. But you have to be traveling quite quickly. But because you're traveling faster than light, even if you, relatively speaking, are not, truthfully speaking, doing that, Okay, it's a trick. It's just like any other Albuquerque, warp drive, tunnel, wormhole, any of that. They're all tricks. This is still just the same. It's a trick. There's a vacuum in front of you. There's no space-time there. You're accelerating it into that. Sure. So that way you're always accelerating at the 1G, but for what it's worth, you're never actually speaking traveling faster than you really, once you started, entered into it. What space and time, which has its own pressure and has its own energy, right, is doing is being used to make you slip through really efficiently, like a superfluid. You have very low friction, and once you come out of it, when you do it well, is a little bit of extra energy to help you continue doing it. So it basically squeezes you through. A good way to think about it is a kind of sort of issue like this. There's this old toy, which is the equivalent of don't stick your dick in that. It's a tube, okay? And if you squeeze on the outside, it rotates towards the center and it goes up towards the top. They tell you not to do it for a good reason, okay? So don't do it. But the point is, it's similar. It's an idea like that. It doesn't do the same thing. Of course, we're talking about a bunch of resonances and a bunch of tube things, but like instead of doing the Albuquerque, which is what that would be doing, this is not what this is. It's allowing it to go through unimpeded and then basically moving something just the right way to basically push off of it. But in so doing, it's pushing off of it, curving it, diffusing it, turning into a bell curve entangle, collapsing it, and putting it out the other side. So that way, it literally doesn't at all, really technically, ever interact with us. Think a water jet got curved just the right way to still remain looking like it's a water jet, like a laminar flow superfluid, if you will, but in so doing, we moved as a result. Now, it takes a degree of energy to do this. If I didn't want to put in energy, I could make it do it by itself. It would take energy and leave a trail of extra cold as to where you used to be. Something you don't really usually want if there are other advanced civilizations or anything that might be able to spot you and track you. Because they could kill you pretty easily. This shit, while the safest version, is not in any way any less, realistically speaking, dangerous to anyone that knows what they're doing to fuck with you while you're doing it. It's the equivalent of, you could basically have all of that go to shit if they made the right field opposing you, and you could explode and die. Granted, I have a lot of measures to not have to care about that. But, most people tend to do that because, hey, that could be the black hole. It's the right spin, the right this, whatever, fuck, right? So you have to pass through a couple of nebulas, stars, orbits, so on, before you get anywhere near that, kind of thing. But that helps you with a large amount of information as to how something could disrupt it, which is a good thing. Because generally speaking, you are very much fucked if something were to happen. But an Albuquerque drive kills you immediately if it ever fucks up. There's no, man, I can kind of get myself out. No, you're dead immediately. A wormhole collapses on you. You did it wrong. You die. Same thing for tunneling for that matter. That's a decent amount of sustained energy that you have to keep, right? Well, I don't have to tunnel. That's the nice part about this, But space-time does technically give us a degree of its energy, which is the whole inflaton and vacuum. But we have to put that back in, which usually means we get a degree of extra out. But, of course, that means it lands exactly where it once was, making it look like, for all intents and purposes, we were never there. It's not going to impart any given mass, charge, gravity, or other at all weakly interacting forces even. is completely invisible, intangible, and doesn't even exist in another dimension. Which, man, doesn't that suck for people? I could be everywhere. Where am I, right? But the whole point is, yeah, I'd rather be stealthy and incognito if I were to do that. Plus it definitely makes it so I don't ever have to worry about any particle fusion at all. Like, I literally will never have to worry about anything hitting me because it can't hit me. But moving space and time, while I describe it like this, isn't technically what I'm doing. I'm slipping through it in a very fluidic, super variety manner that has basically no friction, but it's a workaround version because, of course, there is friction. you know. And when I say I move something kinetically, it's because it has mass, and of course that mass has to match things, and so that's the whole frontward version that then has to work together with the side to the rear. Now, the reason why the fisheye lens kills you is pretty obvious. That information is being deposited and it has to traverse. We don't ever want that information to touch us. That's a bad thing. That information coming back disrupts all of the information that we're ultimately at. So it says, no, actually, you were right there, but you're actually right here. And actually, because you can't be going that fast, and but also, by the way, super also here, you exist in a finite nothing point, which cannot be possible. Which now turns it into, behold! Kaboom! All of a sudden, big explosion. Yeah, a big amount of quantum foam suddenly appears, and it becomes quite sparkly, anything you want to do, quantumly speaking. Very veritable Marvel DC Universe levels of bullshit magic stuff. I wave my hand, you get flown so far. Granted, also, there's a big other reaction for sword. But, calculate all that for what you were. Because, of course, you were traveling faster than light. So you dumped energy that's faster than light at that point into something that had mass. Which is dangerous extraordinarily. So don't ever have the fisheye lens touch. But luckily, that's usually very, very, very far away. Even though it looks like it's somewhat close, it's usually in the hundreds to a few light years away. Although I've seen, in my calculations here, very close to like an inch off of someone if they wanted to do that. And it wouldn't take much for them to collapse onto that. And that's so dangerous. I don't know why they would do that. It's super hyper inefficient. The further away you go, the more efficient it has become, for that. So, like, you want efficiency, you want to do that. But if it was something where you barely have the energy and all this other stuff, I suppose you could do that. And if you were willing to leave a trail for a little while, you could absorb some of that for a bit and then get that further. But if you couldn't, I suppose you'd have to do it. But we are talking faster than light, and you can input a decent amount of energy. Okay, but the real problem here is if you want to do superclusters, that's usually gas tanks, like a good V8, strong 300, 500 horsepower, all day, right? Worth of energy. If you were to start at that 60% the speed of light, yeah, it'd be roughly that. It'd be curving towards the sun to start doing that, and you use that gravitational acceleration actually pointed directly at the star, and you go through it. Usually, you'd be typically around Neptune, and you try and slow down, and just start accelerating more and more and more and more towards it to be able to get that 60% speed of light achieved and start dumping in energy as a blue shift and all that starts to occur, and you can get more and more out of that given maneuver. By the time you get towards Earth, you'll start seeing it, get more and more expandy, I guess. By halfway between Venus and Earth, you should have disappeared to us, outside observers, and are, all intents and purposes, looking like you're heading towards the star, where there's a little tiny, tiny amount of a hole there. And that is all you get. Then it disappears into a big black hole, right? And then the shimmery kind of sides happen, and then, of course, the rear becomes far more fisheyed, although it was already kind of there, but not quite there. It was already pretty far away, not the inch, which is lucky. It's more like a mile away, right? But you wouldn't really see it like that. It'd be right on your ass, which is terrifying in a lot of ways. However, by the time you get to Venus, it will have significantly distanced itself, and of course, little tiny pinprick is decently, the size of your fist. And of course, by the time you get to the star itself, it has disappeared. So that's what you would do. Usually, if you want to do that, and you want to spend that kind of energy, which you do usually have that kind of energy to spend. However, the reason why I say point at the sun is because there's a lot more gravity in that thing. I'm going to use that. I'm going to get some good distance. Let's get to Andromeda, right? I could easily get to Andromeda from there, yeah. Oh, truthfully, that wouldn't be that hard. If anything, I'd probably point myself towards its black hole, just because then I could get an extra jump from that. But, that's kind of scary. There's a reason why I pointed myself towards Sagittarius, and I took a slower, longer, circuitous route that spent 3 years accelerating by 3G for that long. I want to test a whole lot of things. If you already had the information, then you just probably do that. But otherwise, there's no way I would do that. It would be terrifying. It just would be a mind-bogglingly fast way to get yourself a few, because, by the time I get to the Sagittarius A star, I'd be traveling fairly quickly in the faster than light, right? But I would have spent a lot less energy. For its worth, I would still be able to get probably that 10,000, out of that Sagittarius A star, but because I'm traveling from a core of a star, and that I can absorb as extra heat and energy there, right? I'm now able to get far faster than before, and I can just dump, instead of onto the moon, I could just dump into the star, yeah. Oh gosh, every time I think about that, it is kind of scary, because I can actually absorb a good portion of that and run it through. So what that would turn into is I can get probably a good solid 1,000 supercluster kind of distance, right? And then I'm heading that faster than light level of speed into the black hole, which would normally give me usually in the Sagittarius I star range, 10,000 range of supercluster. Well, considering there's only so many, then that one little maneuver would probably get you right out, if it is such that there is that kind of thing going on with the universe outside of the universe. But of course, you would have to have done the first one to really know if you could do that one. That kind of thing, which is a scary, terrifying thought. But I would do it if I had enough knowledge, that kind of thing. Because that would be going through probably the moon. I'd point at the moon and I'd try and swing back and then do that. It's does it go through a solid planet? Well, let's find out. Right? Hey, did it? Well, it did. Oh, I died. 2 options there, really. And that's good because, I can radio control that, and there's no way I'd do it in person until I determined whether or not which side it landed on. That standard, I'm going to hedge my bets here kind of thing. Yeah, standard research development, testing, and experimentation. Standard stuff. Yeah. But that's why I developed the reverse bell end aerospike engine. Suck my dick and balls. Like and subscribe. Share if you will. See ya.